Hello students, today we are going to discuss very important topic, that is reduction reaction of organic compounds. We know organic compounds can be reduced and can be oxidized, but the reductions and oxidation of organic compound mainly depends upon the nature of the reagent used. Depends upon the nature of reagent, the nature of product also change. So today mainly that we will discuss what are the different reducing agent used and what are the nature of product form for particular organic compounds. Let us discuss. Here you see the first that is Birch reductions. Here Birch reductions mainly used by using sodium and ammonia ethanol. Is a mixture of sodium metals, liquid ammonia and ethanol. This is the called Birch reduction, and this reagent it reduces for specific organic compounds. For benzene it reduces, that Birch reduction gives, that is cyclodiene is formed. Benzene convert to cyclodiene. Here what happens? Here both double bonds remain in isolated forms. There is no conjugation. So benzene under Birch reduction convert to cyclodiene, that is isolated double bonds. Similarly, that is important condition if the benzene is attached to electron donating groups. Any electron donating groups like your methyl groups or any alkyl groups is attached. So any electron donating group is attached to benzene ring, then Birch reductions gives that isolated cyclic compounds, isolated double bond, that is cyclic compounds containing isolated double bonds. But condition is that electron donating group is just, it is the end of the double bond. Double bond in isolated position, the product, the double bond in isolated position, and the group, electron donating group present at the end of the double bond. That is very important, that electron donating group attached to benzene under Birch reduction produce isolated double bond, and the electron donating group attached to the end of the double bond. This is very important, these two things. Then next one is, if electron withdrawing group is present, then under Birch reductions, here what happens? The electron donating group attached to the ring where the two double bonds present in isolated position, and the electron donating group present just at which position? Allylic position. This is the allylic position of the double bond. Allylic position. Double bond electron withdrawing group present at the allylic position of the double bonds. So you see the difference. Here electron donating group is present at the end of the double bond, then double bonds present in isolated position. Here the double bond present in isolated positions, and but electron withdrawing group present at allylic position when the group is electron withdrawing group. So this is also very important properties of Birch reductions. Then if any haloarine, you have halogen attached to benzene ring, Birch reductions produce same isolated compound, that is cyclodiene, and double bonds in isolated position, same like previous. This is very important. Then another important reduction of that is Birch reduction, that if the compound is alkyne, then if it is alkyne, then what happens? Under Birch reduction produce trans alkene. Here result is alkene. Triple bond become double bond and the product is transformed. Birch reduction gives trans alkene. This is very important. This is also very important reductions. Okay, then second type of reduction is Lindlar Catalyst. Lindlar Catalyst is the mixture of palladium, barium sulfate, hydrogen gas in presence of xylene, and sulfur also can be used. So this mixture, and this palladium, barium sulfate and hydrogen, this main the reducing agent is hydrogen, and but here catalyst is palladium and barium sulfate and solvent is xylene. Here what happens, what is the main difference between breach reduction and Lindlar catalyst, that is Lindlar catalyst reductions? Here it gives mainly trans alkene, but it gives is cis alkene. This is very important. This is the difference. On Lindlar catalyst reductions, your triple bond alkyne will be converted to cis alkene, but in breach reduction alkyne will convert to trans alkene. This is the difference, very important, try to remember. Then Lindlar catalyst also reduces acid halide to aldehyde, that is a part of Rosenband reduction. So acid halide is converted to aldehyde. This is also called Lindlar catalyst reduction. Then third type of reduction is Mendes reduction. Here in Mendes reduction mainly it is a complete, very important, it is a complete reductions. In both case you see triple bond convert to double bond, that is partial reduction. Here triple bond convert to double bond, that is a partial reduction. Here you see 3 triple bonds is there, but double bonds are remaining, only one is reduced. So these are only called partial reduction, but Mendes reduction, that is called complete reductions. Here what are the reducing agent? Reducing agent is that hydrogen and nickel, sodium and alcohol, tin and HCl, lithium aluminum hydride, that is short form is LAH, that is also called LAH, lithium aluminum hydride in short form. So it can be also used. Its role is it reduces any triple bond to direct single bond. That means nitrile will be converted to amine, primary amine, and isonitrile will be converted to secondary amine. Just you see, every case triple bond is converted to single bond, and this case also triple bond is converted to single bond. So this is called complete reduction, that is Mendes reductions, different from Lindlar reductions and breach reductions. Okay, then fourth one reduction is Stephen reductions. This is also a partial reductions. Here what happens, same nitrile is converted to that amine, it is converted to imine, and that imine on hydrolysis produce aldehyde. This is very two steps. This is a two-step process. In the first step it will be converted to imine, then imine under hydrolysis convert to aldehyde. So this is called Stephen reductions, partial reductions. Then reduction by DIBAL hydrogen. DIBAL hydrogen means diisobutyl aluminum hydride. Diisobutyl aluminum hydride, DIBAL-H, diisobutyl aluminum hydride. It is also one important reduction agent. But here also in Stephen reduction, what triple bond, double bond cannot be reduced by Stephenson reductions. Similarly in DIBAL reduction also triple bond, double bond cannot be reduced. Here it is same. Here nitrile will be converted to aldehyde and ester also convert to aldehyde. This is very important in DIBAL reductions. In DIBAL reduction what happens, nitrile is converted to aldehyde and ester also convert to aldehyde, but triple bond, double bond cannot be reduced by DIBAL hydrogen and also by Stephen's reduction, that is stannous chloride and concentrated HCl. Another important reduction is Bivolt-Blanc reductions. In Bivolt-Blanc reduction what happens, that is sodium and alcohol is used. Here what happens, aldehyde, ketone or ester convert to alcohol. This is very important, conversion of aldehyde, ketone, ester to corresponding alcohol. RCHO aldehyde, BBR means Bivolt-Blanc reductions, and BBR on reduction produce alcohol, and ketone convert to second, this is primary alcohol, this is convert to primary alcohol, this is convert to secondary alcohols, and ester on reduction of BBr convert to two types of alcohol, because this part will be divided into two alcohols. So these are called Bival-Blank reductions. Mainly the reagent is sodium metal and ethanol. Mainly use Bival-Blank reduction. It reduces aldehyde, ketone, ester to corresponding alcohol. Selective reductions. Particular reducing agent produce particular product. You see the very important the difference. This is, you see, this is your 2. If you count the number 1, 2, 3, 4. 2,4-dinitrotoluene. The main reagent is 2,4-dinitrotoluene. And this reagent, this compound undergo reduction by ammonium sulfide. It is selective reductions. Under ammonium sulfide, it reduces which one? That is your para. Para nitro group will be reduced, but not ortho. This is para. Para will be reduced. Out of two nitro group, one group will be reduced, other remain same. Other will not be reduced. Which nitro group reduced by ammonium sulfide? Only para. But in stannous chloride and HCl, it reduces which one? Ortho. Ortho nitro group will be reduced, but in ammonium sulfide, that is para nitro group will be reduced. You see the difference. That's why it is called selective reductions. Ammonium sulfide convert one nitro group to amine, but which nitro group? That is para. If the group is electron donating group, then at the para position will be reduced. But in stannous chloride and HCl, the ortho nitro group will be reduced. So this is the very important difference between the selective reduction of nitro compounds by using ammonium sulfide and stannous chloride and HCl. Similarly, another reduction is reduction of nitrobenzene. Particular nitrobenzene can be reduced by different different reducing agent. Here is stannous chloride. Here tin and HCl. It is also a reducing agent. Tin in nitrobenzene acidic medium, it convert to what happens? You see the difference. Nitrobenzene in acidic medium, it is convert to aniline. It is convert to aniline. But this same nitrobenzene in presence of, that is neutral medium, zinc and ammonium chloride, that is neutral. This is neutral. Neutral. In neutral medium, convert to, that is hydroxy phenyl, that is phenyl hydroxylamine. This product is phenyl hydroxylamine. So this product is produced from nitrobenzene in presence of neutral medium. But in alkaline medium, three types of product is formed. One is, that is azobenzene. This group is called azo group. This group is called azo. So azobenzene or azoxybenzene, or that is hydrazobenzene. Three types of product is formed. You have to remember in alkaline medium. Nitrobenzene in alkaline medium produce three types of product. That is azobenzene, NNN, that is azo group, and phenyl group, azobenzene. Then next one is which one? Azoxybenzene, that is oxygen containing azoxybenzene, or hydrazobenzene. Hydrazobenzene means hydrogen derivative. So hydrazobenzene or azoxybenzene or azobenzene. These three types of product is formed when the nitrobenzene undergo reduction in presence of alkaline medium. Then very important types of reduction is lithium aluminum hydride and sodium borohydride. These two types of reducing agent is very important hydrides, acts as a mixed, that is complex hydrides, and these their reducing properties are different. A very stronger reducing agent is lithium aluminum hydride compared to sodium borohydride. What is the difference? Just let us discuss. Suppose it is ester. Ester cannot be reduced by sodium borohydride. Okay, but ester can be reduced by lithium aluminum hydride. This is the difference. Lithium aluminum hydride LaH can reduce ester to alcohol, corresponding alcohol. This is the alcohol position. It can be converted to alcohol. Ester will convert to two alcohols by LaH, lithium aluminum, but NaBH4 cannot reduce which one? Ester. Similarly, very important thing is, if it is alkene cannot be reduced by LaH and NaBH4. Both cannot reduce alkene. But if the alkene is attached to phenyl group, it can be reduced by LH, because LH is a stronger reducing agent. It can reduce this compound to alcohol. This is also very important. Remember the difference between LaH and NaBH4. First difference is, it cannot reduce acid and ester by NH4. NaBH4 cannot reduce ester and acids, but LiLH4 can reduce ester and acids. Also aldehyde ketone can be reduced, but double bond cannot be reduced by both. But if phenyl group attached to direct double bonds, then it can be, that is alpha position. If alpha position contains phenyl group, then it can be reduced by LH. It produces alcohol. Then last very important reducing property that we are discussing, Rani nickel and hydrogen. Because Rani nickel is a very reactive nickel used in the reduction, specific reductions, that is called Rani nickel, and is a nickel that in presence of alloys, nickel aluminum alloys and hydrogen. These called Rani nickels, and when it is heated, then what happens? It converts triple bond, double bond to single bond. Is very important. It converts which one? Triple bond, double bond can be converted to single bond by Rani nickel, because Rani nickel is very reactive reducing agent in presence of hydrogen. And very important thing is, benzene can be converted to cyclohexane. All triple bonds can be reduced to single bond by in presence of Rani nickel. But your plain nickel or palladium, platinum use, it cannot be convert benzene to cyclohexane. So this is the very important, some important reducing agents use. Specific reducing agent can reduce the particular organic compounds to the specific product. So try to practice this one. If any question you have related to this specific reductions of organic compound, so you can send your question in the comment box, so that we can discuss the question in the next class. So try to practice this one. If you have any question, if you have any doubt, you can send the question in the comment box. But don't forget to share the videos. If you like, please share the videos, press the bell icons and subscribe the channel. Then any doubt you have, you can send your questions in the comment box. Okay, thank you all.